In this video, or in the next few at least, we're going to add the air movement to the character. Jump, fall, and the transitions between animations. The character might look a bit weird right now with the animation, like it jumps a bit like a monkey. You'll see that it feels a bit better when the camera is following him, which we'll work on in the next chapter. So going back into the matrix, we're going to add the jump to the character, open the player scene, and we're going to create a new state once again. So from move, is going to be movement related, so it's also going to be based on the move state. Add a new player state, and we're going to rename it to air. We're going to handle jumping and falling. Everything is air movement for us. It's something we've used in a few demos instead of splitting the jump and fall states, and it's working pretty well. So right click, extend the script, and let's create an air state script in the state folder. I'm going to close the other tabs, and the first thing we have to do is to create a transition to that air state so that we can test it. We're going to do that in the move parent state, because regardless of the state we are in, as long as the character is on the floor, we want to be able to go to the air state. So placing a transition on the parent state in a hierarchical state machine saves you a few lines of code. We're going to create our unhandled input function. Don't forget to remove the leading underscore, as it's part of our states interface. And we're going to transition to air whenever the jump action is pressed. So if event.is action pressed, and we're going to create a new input action in the project settings, input map tab, create one called jump, and we'll place it for the keyboard. We're going to use the space key, and on the gamepad, I guess we can use the A key. So I want, if the jump action is pressed, to transition to the move/air state. So this is the first time we're going to use our message dictionary. Remember that the transition to function takes an optional second parameter, a dictionary that has keys and values. This can be anything you want that you want to use in the other state. In the air state, when we jump, we want to preserve the character's velocity most of the time, or to be able to use it to react to it. So let's add a key called velocity, and we're going to assign the value of the velocity variable to it. This is a valid dictionary in Godot. The key is always on the left side of the equal sign, so it doesn't matter if you are shadowing an existing symbol or variable name. And on the right side, Godot will understand that this is the value, so it will take the value of the velocity variable. And then we'll have something, the jump impulse. We can also pass it there. The idea behind that dictionary is that, well, if you are coming from different states, maybe not a move state, you might want to pass a different jump impulse and velocity. Say you fall on a bumper. The bumper is going to make you transition to that move/air state, and maybe the jump impulse will be much higher than the one that you have. You can have conditions that change depending on the current context. This is why you want to pass this information through the dictionary instead of reading the values directly on the parent move state. But with that, we have a transition set, and we can get started with our air state. We're going to use our usual interface there, so I guess I'm just going to open the idle state, copy the code there, go back to the air state, and paste my boilerplate. Once again, we're not going to use unhandled input in the air state. The character is just going to go up and then down through the effect of gravity. So you can keep the first line calling physics process on the parent, and then we're going to have some conditions for the transition. It's very similar to what we had in the idle state. When the player touches the floor, so if it's on floor, then you're going to transition back to, we can transition directly to idle. And if you have a key pressed, the idle state will transition to run. So here, to be thorough, you could check for the input direction, if there is any. So you could say var input direction is equal to parent dot, and the function was, I'm going to go back to the move state and copy get input direction there. And so if there is an input direction, then we transition to not idle, but we transition to the run state, else we transition to the idle state. There we go. Oh, and of course I need to say that it's a vector 3 because my parent is not being casted as the move state. There you go, you can do that, but to be honest, in this example, it works to not have all the transitions explicitly, jump transitions to idle, that transitions to run. And that's about it for now. Now remember that in the move state, we are passing some velocity and jump impulse through the message dictionary. So going back, we are going to apply that dictionary to the character. Now here's some interesting trick that you can use with the match keyword in GDScript. It's one that's fairly underused. It's a pattern matching mechanism. And when you match a certain structure, you can store some values in variables. Let me show you what I mean. We have a dictionary. So we want to see if we have a dictionary with a key called velocity and a key called jump impulse, right? And if that's the case, we're going to store the value that's assigned to that key, that corresponds to that key, into a variable. So let's create a variable v for velocity for the jump impulse, ji jump impulse. You could use longer names, but in that case, that's the only place where they're going to be used, so short names are fine. I'm going to put a colon at the end of the line, and if we have a dictionary with that structure, we can say parent dot velocity is equal to v, so that velocity up there, that's going to be preserved in the jump state, plus a vector 3, and that's going to propel the character up. So the x component is equal to 0. The y, remember, the y-axis is the up-facing axis, so we're going to apply the jump impulse, and we're going to use 0 for the last component. Normally we don't use short names at GDQuest, but in those cases, in lambdas, in structures where the variables are created and instantly used only once, like the reason is that when you're reading the code, you see the velocity key and the value corresponds to velocity. Jump impulse, we use the initials. Again, this is not something we would do in a larger code base where you have to reuse these variables. Anyway, we're going to make our mannequin transition to the air state. So skin.transition to, and we're going to use skin.states.air. This will play the air animation, or the jump animation in our case, that we'll add in a moment. But first, you have the logic for the air state. So I hope that by now you can see the power of this hierarchical state machine, where we are barely coding any movement in our child states. We are just slightly modifying the velocity here, applying some impulse, but the calculations are taken care of in the parent state. If you don't have a hierarchical state machine, you end up having to recode the movement in every individual state. I should select physics process because that's where you would do it. But with that, you can normally play and have the character jump. So it goes back to the idle animation, because remember that on Mannequin, we set the default animation in case a state isn't taken care of in transition to. We're going to play the idle animation. And we'll add that animation and the remaining transitions in the next video.